Okay, so I'm going to be going through this challenge. This Git challenge, we're going to be implementing a couple of parts of Git. So we have like 5 objectives. So this is the core data model. There's a commit object that points to a tree object and directory. And within that, we have a blob object, which is like a file content, and a tree object, which is a subdirectory. And that tree object will consist of blob objects. So a blob stores raw file contents, no file names, no permissions, just the file itself. Then the tree stores directory structures, so the map file names, mods, and SHA1 hashes to blobs and trees. So yeah, we'll get to see exactly how that looks like. So yeah, we'll be implementing this in Rust, and let's begin. I think my audio is not very good, but I won't be doing a lot of talking. We'll let the code do the talking itself. So yeah, let's go. So it's going to initialize directory. That's a new Rust directory. You have a main function here. Print hello world. Personalizer there is initializing. So these are not dependencies, just bare Rust. Just to run it. We are printing hello world. So the first objective is to set up this command, the init command. Everybody's familiar with this initialization. So this initializes the Git directory, the .git. So the first objective is create a .git directory, create a .git objects, git refs, and git head file containing this. Okay, so at the end, after initializing, print initialized empty git repository in .git, or exit cleanly with code 0. So in order to do this, we're going to use clap. Clap is this library, this Rust library, which parses command line arguments. So it just makes making an application very, very sorry for that. So yeah, it makes creating command line applications, which taking lots of argument way easier. So we're going to add clap with the derive features. Derive features will just make our jobs way easier. So let me just copy paste some code from the where's derive? I'm not looking for this. I want subcommands. Subcommands, please. What are the subcommands? Subcommand. Come on. Where's that example? There's a example I'm looking for. Yeah. This is this is what I'm looking for. So I'm just gonna copy this. And just this as well. Can remove that now. Yeah, I think that's it. Let's just get into this. Let's just remove some things we won't use. So this will not be an option. We don't want this to be an option. And okay, but we'll use that. I just I don't want to see warnings all the time. But I'm sure we're gonna use path. So this is not taking in any arguments, and we're gonna call this init. So this is our first command. So we're gonna have other commands. So now I'm going to match this command, and yeah. So instead of using sum, since we already have our commands, if it's init, which takes in no arguments, we want to do this. Yeah. Expected unit stat, not a unit structure. How is this defined? Yeah, no, I think that's fine. So what are we supposed to create here? So git directory, so we want to create dir. So I think that's part of the standard library. So maybe, yeah, create a new directory the provided path. This function currently corresponds to the make directory function Unix. Okay, no problem. That's exactly what we need. So we want to create the .git. So we're not gonna use path. Taking a new data grabs a string of the path slice. So yeah, because at least when you use path, instead of just using directly, just using the path directly, path takes into account. We're gonna use the directory or instead of just plain, because with the directory or it's gonna create even the subdirectories that we need. So this would be, so we can just go at it and just say create objects. So this will then create we'll create both folders. Does this require, what does this require? We'll get back to that. Good. Path new again. So git ref. Is it ref? Refs, and we're also gonna create. Not sure. That's so strong. So create a git head file containing that. Okay. So we're gonna create a file. Create, opens the file in write-only mode. So yeah, that's what we're looking for. Takes in a path. So this returns a file, so we can just say .f equal to file. Okay, exactly what we need. Okay, so then I use path again, new. So git head. It's then I'm gonna write to the file. How do they write to the file from here? So that's the result. I'm gonna have to propagate the error. So I think we're gonna use anyhow. I like anyhow. Always use it. result. Okay, so we have our file now. We're trying to write it. Let's see the example. Write all. Okay, no problem. Write. What's a buffer? I don't want a buffer. What can I use here? I'm gonna use write all. Write all. So what they want is a file containing refs head main. So 2 bytes as bytes. Yeah, so that's all. At the end, just print line. Initialized empty git repository .git expected unit struct. What's going on here? Should the unit struct font struct commit, not the unit struct invariant. Is the struct variant pattern? Is the struct pattern? What does this want? What do you want, my good sirs? Maybe it needs me to put in an empty. Okay. So we need to propagate the errors here. So we're going to add context. Failed creating objects directory and context. Failed creating refs directory, and we propagate the error. Then now failed writing to file. Alright. Okay. So yeah, I guess that should be it. Just remove this. Okay, we're good to go. But the only problem now is that with cargo new, will initialize, will make a git directory for us already. So we're just gonna, let me just remove this. I'm gonna remove the initial git directory so that we can create a new one with our command. So the way we run this now, cargo run and init. So let's go. Initialized empty git repository in .git. Let's see if it's actually there. So it's actually there, and the head is actually there. Yeah, so everything is great. Okay, so let's go to the second objective. Read blob object. Read decompress and display the contents of a stored object by its 40 character hex hash. So the trigger should be git clone cat file. There's this argument p. I think it's it's supposed to be pretty print. The actual git has a pretty print. You can put in a pretty print there. Then the 40 character hash. So deliverables split hash into directory 0 to 2. So we split at the second byte. Yeah, second character. And file name. The file name is from 2 to the 40th character. So we open .git objects directory files. The directory we're gonna get it from here, from 0 to 2, and the file we're gonna get it from 2 to 40. Then decompress the data using zlib decoder. Parse the header format, strip the header null byte, write the root file content to standard out without trailing new lines. Okay, so we need zlib decoder. Anyway, we'll get that. So cat file, we're gonna add a new command here, cat file, and this is gonna take in an argument called we're gonna call it tree hash. Oh no, character hash, object hash for the win. So be a string. So I'm not gonna put in the pretty print here because there's no reason to pretty print. There's no deliverable that requires a pretty print. So the pretty print, I'm just gonna ignore this ./p. I'm just gonna focus on the object hash since it doesn't seem to matter here. So now cat file, so cat file comes in with that object hash. So what we can do here, just to be a better man, we can just create a separate module. Since if we just use this main.rs, it's gonna be very untidy. So we're gonna create a cat file, we're gonna create commands submodule, then we're gonna create a cat file there, then the cat file we're gonna create an invoke which takes in an object hash. And yeah, gonna pull the error. So yeah, of course you cannot find the module, creating it right now. Commands.rs, then here gonna have mod called cat file. File is not included anywhere in the tree, so we need to include it somewhere here. Mod commands. It's included. File not found. Of course, I haven't created it yet. So let's create it now. Okay. So there we have our cat file. Then here we're gonna create a public function called invoke, but it's gonna return anyhow result. So since it doesn't really return anything for now, okay. This function takes in 0 arguments. Object hash. String. Just want to make sure nothing is too crazy here. Expected result because of return type. Okay. What are we returning here? Okay. What's this error saying? Has incompatible types, operator can convert blah 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 to blah blah blah, expected blah blah blah, found blah blah blah. Okay. So back with objectives. So in order to get this this object, because this object right now it's compressed. It's compressed, so we're gonna have to get into the directory, get the object, decompress it, and print it out to our standard out. So in order to get this, we're gonna have to split the object hash, right? So we're gonna split it into the directory and the actual file, and it's pretty straightforward since we're already using a string. So split at 2. So yeah, just like that, we have our directory and our file, right? So open. So I want to open. What can we use to open? So let's open a file. So I'm gonna call it f and use the standard def as file open. So open, yeah. So I'm gonna use path again. Path. So what are we looking for here? Okay, I think it would be better to just construct the object path. So let's just say object path is equal to, we're gonna use a path buff. So this is pretty good when you, so we use from here, from dot get objects. So path buff, then you can just say object path dot push dir object path dot push file. Okay, yeah, that's better. That's way better. Object path. What's going on here? Cannot borrow object. Oh, sorry. It needs to be mutable. It needs to be mutable. All right, my good man. Here, there you go. It's mutable. So here is an error. So let's just add some context. Failed opening file. Failed opening object. Let's say compressed object. Compressed object. So propagate the error. So we have a file, and we want to have, because once we open the file, we need a reader. So we can use a buff reader. You can just say let reader. Need to read the file, so buff reader. It works pretty well. New is new, okay? Yeah, new is perfect. F. So yeah, we'll have a buff reader. So now we'll have a reader, and we need to decompress the data using zlib decoder. So let me just go through. Let me just go to the zlib rust zlib decoder. Zlib decoder. Yay! Let's go. So read. Yeah, exactly what we want. Beautiful stuff. Copy. Paste here. Oh, let me add it. So the library is Flate2. It's a compression and decompression library. Flate2. Let me sip some of my coffee. Okay, coffee sipped. Let's get back. Okay, so we want to do this. Let me just yeah, let me just copy this. So yeah, so so here we're gonna pass in our reader, and we're not gonna use a string because the thing with these blobs, these git blobs, not all of them are going to be strings. Sometimes it could be an image, it could be a video, you know, it could be lots of different things. So we're just gonna use a Vic, and so we're not gonna use read to string, I'm gonna use read to end. And so now our Vic has the object, and now what are we gonna do? How are we gonna display this out? Okay, so zlib decode has been decoded. What's the requirement? So pass the header format. So as it is right now, we're gonna have once you open the file, once we read the file, we're gonna get like blob at the beginning, the size of the blob, and this 0, the null. Then after that, that's when we're gonna get the content. Right, so we need to strip the header and null byte. So just get rid of this and just have the content and print the content out. Okay, so since it's a Vic, so we wanna get the position, right? The position of the 0, the null. So null position. So what are we gonna do here? S dot position. So just for an element in an iterator returning its index. Yeah, exactly. So what x is equal to 0? Should we use x is equal to 0? We'll see, whatever works, right? So I think, yeah, I'll show you 8. Okay, I see it's an unsigned integer. So I guess we can just say p is equal to 0, and context failed to get now position. Okay, so we have where our null position starts, so we can just say let the content is equal to s. Let's just borrow that. I think borrowing will be easier. So we wanna get from the null position to whatever is left. So that's our content. Cannot be indexed by blah blah blah. What the hell? Oh, okay. So now we have our content ready to be printed out. Okay, so what do we do here? Standard out. Okay, standard out. Let's see if we can use the actual standard out function. So you handle the standard output of the current process, each handle, blah 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 blah. Standard out. We import that. Standard out. Okay. Dot write all. Exactly. So yeah, this takes in a buffer. Yeah, basically a list of U8s. Basically, exactly what we need. Okay. Let's add some context. Failed to print to standard out. Propagate the error. Then we're good to go. So we just need okay, we just need a file because we just initialized the git thing. The git thing. Sorry, we just initialized. We've just initialized the git repository. So there should be no objects there at the moment, but we can create an object. How can we create an object? How can you create an object? How can you create an object? How the fuck do we create objects? Sorry for the language. I won't do that again. Clone. Yeah, hash object. Yeah, hash object works. So let's just try with the cargo.log. So this is our hash. So I'm using the actual git. I use the actual git to create this object. So we're gonna use this hash and see if our function will be able to print out the cargo.log. So cargo run cat file. Let's go, come on. Let's go, here we go. So this is our cargo.log. So cargo.log file. So you can see here, so this was the actual hash object, right? This was the actual hash object. So what it did is that it went into git and it went into objects, and the directory will be d2. So do we have a d2? That's the only thing that's there. So it went into d2, and it trade that. So I'm sure if you try to open this, it's gonna be all gibberish. Oh, sorry. Let me just nvm in nvm. See that? So it's a zlib decoder which gets into this and decompresses it. Okay. Well, looking good. 2 out of 5, I guess. Is it 5? Just sipping my coffee right now. Okay. So write blob object. Write blob object. So yeah, that's the function we just used right there. Which makes me think maybe this should have been objective 2 than this objective 3. But I guess we get to write it, forget to read it first, then now we can write. It's alright. So write blob object, right? The command name should be hash object, should take in W. So I'm going to ignore the W again since we're just writing, we're not gonna do anything else, so I'm just gonna ignore it for now. So we're gonna take in the file path. So read row byte contents of the target file, construct the header plus content payload, so blob. So this is how we're gonna construct it the way we were basically parsing it, right? So blob, we're gonna put blob here, the size in bytes, the 0 here, then the content of the actual file. So we're gonna have to calculate the 40 character hex SHA-1 hash of the payload, compress the payload with the zlib encoder. We're gonna use the same zlib, the same flate package to do this. Then we're gonna save to git objects hash 0 to 2 hash 2 to 40, then print the SHA-1 hash to standard out. Okay. So what's the command? Hash object, hash object. So we're gonna take in the file path, which is going to be a string, that is O hash object commands hash object invoke and taking file path. Okay, so we're gonna go to commands, add another hash object, gonna create this, and I'm gonna put in the invoke file path making a string, and for now, anyhow, nope, not that, anyhow, result. Okay. Okay. So write blob object. So we want to read the file. I want to open the file and read the file. Okay. So what's the best way to do this? Okay. File. Should I do this or should I do the other thing? Anyway, let me make it clean so that people can see what's going on. I'm just gonna call it I'm gonna call it file path again. Okay, let me just call it let path. I'll see once I just get a visual on it. So let path, and let's create a path new file path. So now we want to open the file. So this file open again, and we put in the path, and context field. I think here we can just use with context. Should we use with context? Should we not use with context? Who knows? Who knows? I know. We're gonna use it. So format field open file. And here you can just put in file path. So we have a file. We want to read it, so we're gonna summon our reader again. Come here, reader, buff reader, and we're gonna take in our file. So we have a reader, so construct the header. So okay, we want to construct the header. We want to construct the header. What's the best way to go about this? So want to read and have the bytes. But so we can only calculate the SHA-1 hash of the payload once we have the entire thing. So we're gonna have to have the bytes and construct this. So what's the best way to do this? Let me just sip some of my coffee. Maybe I'll be enlightened after. This should not be a big problem. Okay, so we have our reader, right? Let me just check out that example again. Reader. Okay. Read to end. Yeah. So let's just store. I'll call it blob. So store the actual bytes. So reader read to end. So you can just store that in our blob. Store borrow reader as mutable. Want this to be mutable. Also want this to be mutable. Context me just use with context again. Okay, with context. Failed to read file back there. Let's go. So we have our bytes in the blob now. So let's just construct it so it's like that. Okay. What's so size in bytes? So the size of the file. So we can get the size of the file first. Size of file from blob should be len. Yeah. Get that blob. Okay. So you want to do a thing. You want to do this in such a way that we keep it in the vec. We keep it in the VQ8, and we also keep that in the VQ8. I think we can create another vector. So let's just say formatted. Let's call it formatted data and another vec new. Okay, whatever. Then we can what can we do here? Formatted data. Maybe you can just construct another reader. Is that ethical? Is that even ethical to construct another reader? How can one have 2 readers? Can't. That's unethical. How the hell do I do this? I can just create a list of bytes. You can just turn the actual thing to bytes. So maybe you can just create a string. Okay, so first part. Let's call it first part. Let's just create a string. So we can use format. We can just say blob. I don't know, maybe there's a better way, but right now I'm just gonna size of file. I'm just gonna create a string, then turn that into bytes. Then I'm gonna extend that list of bytes with the initial file content. I think that makes sense. That should work, right? That should work. So like this. Okay. So we have a string, but let's say as bytes. Yay. Then I can just say extend. Come on. What is the function that I'm looking for here? Come on. I'm not. Is the function I'm even looking for? Does it even exist? Is it just a dream? Could be just a dream. Or is extend? What? Okay, I'm not gonna do that anymore. But we do have a list of bytes. So you're telling me I can't extend this. I can just add another slice, copy from slice, clone from slice, add slice. There should be something to do with slice. But there's a way to because come on, complete fail. To work around this, That should be maybe push. Can I just push? Can't push. Okay, but can I just say to vec then? To vec, right? Then push push the blob. Come on. E8 found blah blah blah. How about now? We have that. No, we do not have that. What can we do here? Found that. So vec. I need vec to be in bytes. Expected U8. Is there a suggestion here? Incorrect. Incorrect. Mismatch type. Expected type U8. Found struct vec U8. Huh. Come on. Rest. Okay, maybe that works. Is there a Stack Overflow guy? Vector of bytes to a byte array in Rust. What did you guys do? This is so unclean. Such an unclean method of doing this. Come on. My internet is kind of slow. It's kind of bad at the moment. Come on. Load. Load, my man, load. Okay, .vec, but doesn't work. Okay, as slice. Okay, so that's all done. So it's expected U8. Oh, it's expecting U8. Extend. I think I type notation unit for vec first part cannot mutate immutable variable first part. Cannot find value first part in this scope. Type notations needed for vec formatted data. Do I even use this formatted data? No. See, Stack Overflow still working. Stack Overflow is not dead. Okay, tell everyone Stack Overflow is not dead. It still lives. I'm still using it. So compressed payload with Zillibean Coder. Okay, Zillibean Coder. So Zillibean Coder, we want do you still want the read or the write? I think we want the right. Not the read. Where's the right? I want to be in the right. Damn you, internet. Damn you. Zilio encoder. Let's go. So right, so here you can put in that, you can write that to that, and you can finish writing that to that. Okay, sounds pretty good to me. Sounds pretty good to me. So okay. The current scope. So we need to have our right trait imported. STDIO, so right. Innovate new. Okay. First dot compressed. Yeah, so we have so there we have it, folks. It's compressed. It's compressed now. So what's next? Compress payload, then we save. So we need to create the SHA1 string. We need to sort of encode this. So there's this library called hex rust. So we can encode the compressed. I think we can either encode our actual data or encode the compressed data. I don't think it actually matters. I don't know how Git actually does it. I think we'd have to check the source code for Git, but I think either one of them is going to work for us right now. Damn you, internet! Damn you! Hex encode. Okay, but we want the SHA1. Rest. Okay. Yeah, so this is what we want. Let me just cargo and SHA1. Come on, internet, damn you. Do you guys think when you say damn you, the internet will go fast? Maybe I should be kind to the internet. Does the internet deserve kindness or condemnation? I don't know. Those answers must be given. Okay. So let me just copy this. Digest. Yeah, I think we're gonna need the hex too. I'll go add hex. So digest. Let's put in the compressed. I'm not putting the compressed. So we have this weird array which looks pretty weird. When the Rust compiler finds that the Rust analyzer finds that the type is too weird, that the way this is weird. It saves it into a temporal directory. It saves the entire name of the type in a temporal directory. So this is kind of saved in a temporal directory right now. So you're kind of seeing this, just so crazy if you ask me. So hex. So now we have that weird file. So we're gonna use hex in code. Yes, this is what we want. This is what we want. Result. So now we have our 40 character hash. Okay, so we can just print this out and we would be done. Hash. We're done. Okay, I don't know, this was a bit shaky. It's a shaky implementation. It's let's see what happens though. Let's see what happens. Do you guys believe? I believe. I'm a huge believer. So let's hash object, right? Save it as hash object. So we're gonna put in a file path. We're gonna use the cargo lock. The cargo lock. Yeah. Or any of them. Hash object. Okay, now what? Let me just create this is hello.txt. Hello world. Hello world. So we can just run hash object hello. Let's go. Come on. Let's go. We have a hash object. But wait. We just hashed it. We didn't actually write. Did we? Nah. Do I have to? And the instructions don't have write. The instructions don't have write, but you have to actually write it. You have to write it to the directory. Yeah. So let me, because right now it just hashes. It just hashes the object and it prints out the hash. So we're gonna have to write it to the actual directory. So we're gonna write this the compressed data into the directory. Yes, let's just do that. Let's just do that. So let's just split again. Hash dot split at. Then let's just create an object path with the path buff. So from what's going on here? Git objects. Okay. Can you please import this, man? Import that, man. Thank you. So object path push. Okay. Mutable. I don't know why I forgot to put mutable there. Fuck me. Sorry again. Yeah, object path. Yeah, I'll have object path. We wanna write to it now. So let's just create the directory. Make sure that everything is created. So object path dot parent. What's going on here? The trade bound is not satisfied with blah blah blah. object path, the parent. Oh, there's an option. Context failed to write to object, failed to write to. Let me use with context there. The context is really helpful when you're debugging. Anyhow is king for me. It's really good. I mean, right now maybe it sounds very crazy, but I'm just, it's muscle memory at this point. Failed to create object path. Does it have a toString? Doesn't have a toString. Anyway, not gonna bother. Failed to create path. Failed to create object path. Okay, so path is created, and then I want to create a file. Okay, file, create. Okay, file create. Object path. Object path. Object path. Okay, so we've created. That's it. Context failed to create object file. Failed to create object file, and let's forget what's possible here. Okay. Fucking hate the fucking mouse. Sorry again for my language. Compressed. Okay. Move occurs there. Okay, so let me borrow it here instead of moving it. Failed to write to objects file. Okay, and that's it. Let's try that again. Done. Okay. Read tree object. Objective number 4. So decompress and parse binary tree entry structures to inspect directory listings. So the trigger is git clone ls tree name only tree hash. I think I'm gonna ignore the name only again. Yeah, because I'm just gonna print out not name only. I'm just gonna print out everything. So deliverables, locate, unzip, decompress, the tree hash, verify, payload starts with tree size, then parse repeating binary entries sequentially. So the repeating binary entries has a mode, a name, 0, then the actual count, is the 20 byte of raw SHA1. Then pass the tree entries. Unlike blobs, tree contexts are formatted in binary. The passed byte stream after the header null byte is a sequence of entries. Starts mode starts with space separated mode. So that's that or that. Name, the file name or directory name terminated by a null byte. hash exactly 20 bytes of raw SHA-1 binary representing the hash of that entry, not a hex string. Collect entry names, sort them alphabetically, and print each name on a new line. So yeah, I think I forgot to mention, but this is from this challenge is from Code Challenge. Anyway, it's Code Crafters. Yeah, Code Crafters. Now, let me just refill my coffee. I'll be back. Oh, and we're back. So, LS3. Let's go. So again, a read tree object comes before write tree object. Okay, it's fine. So ls3, and it takes in the hash. I'm going to ignore the name only. I'm just gonna print out with the names. So it takes in a hash, which is a string. So a tree hash. Tree invoke, and we pass in our tree hash. So let's just go to commands. Tree and just create this directory. Invoke our tree hash, which is a string, and we're going to return an anyhow result, which contains nothing at the moment because we're not returning anything. Okay, let's go. So locate and zlib decompress. So we're gonna locate it the same way. Even the tree hashes are just constructed in the same way the object hashes are. So 0 to 20 or 0 to 2, it's the file name or it's the directory name. Then file. So we want to read. So let's open it. Let's open our file. Open. Okay. Let's tree object path. Let's just call it object path. I think the best way to do this. The best way to do this is to maybe create like a struct, in a couple of traits. I can do the reading and the writing for us because it's getting pretty repetitive. I've written this code like 3 times now or 2 times. Yeah, but anyway, let's just go. Let's just go path buff. Once you write the same code once you write the same code like 2 times, you're doing something wrong. But let's just continue. We will ask for forgiveness after. Maybe at the end we will try to just we'll try to optimize it. Damn, why do I... And I keep on doing this, right? I keep on not making this mutable. I mean, the entire point is for it to be mutable. And let's have our reader. Buff reader. The best reader of all time. And we can just read that into this. And just say this needs to be mutable. This also needs to be mutable. Okay, so reader, then read to end. Read to end. Tree. There. Yeah, so I think, yeah, this entire thing here, this should be a function. This would be a function. So want to decompress it too. We want to decompress it too. So read. Okay. It'll be encoder. Let's just go to read and get the code from there. Same stuff. Same stuff. Same stuff. Read. Have a read there. This is the right way. Yeah, I've done too many steps here. Could have been easier. Just forgot about them. But anyway, we're just gonna continue. The tree should work. What? It's not implemented for Vic U8. So should we pass in the reader? Yeah, I think we can just pass in the reader. Then we can just not do this. Yeah. And then we can have this should be our tree now. And plus this here. So not read to string, read to end. Does not need to be mutable. Okay, my good Rust compiler, my good man, Mr. Rust compiler. So want to verify that our payload starts with tree. Okay. So if tree dot starts with so these are bytes. So if it doesn't start with tree, we wanna bail on this. So bail. Come on, where's the fucking bail? So there again. Tree is corrupted or invalid. Does not start with tree. Okay, then so the way it is, right? The way it is that after this, right? We have entries, right? We have entries. We have these entries that are stored like this, so it's just like a list of entries: 1, 2, 3, 4, 5, 6. So we wanna go entry by entry, get the mode, the name, and the bytes, and print them at the end. So let's we wanna so what are we gonna do here? What is the best way to do this? What is the best way to do this? What is the best way to do this? So we can use a while loop and check if our entries are still empty. Then we can just be pushing every entry to an entries list. So we just have an entries, just big U. Okay. So we have our entries list, and we want to push to it. So we can just say while tree is empty, is not empty. Our tree is not empty. We want to do a couple of things. So this is when I'm gonna start parsing. So firstly, we want to go to where the 0 is. We want to get to here. We want to get the position of this and start moving forward, because it's gonna start like this, then the entries. So let's get the position of the 0. So now position, so tree, sum on the iterative, position, so e is equal to 0. Context defined, now position. Okay. So we have another position, and now I want to move forward, so we can just say maybe we should do this outside. So this so that we can just say let tree is equal to tree, then just get everything that's after this. So from here. Okay. Okay. So now we are past this point, and now we have a lot of entries. So we're gonna get the first space, right? So we're gonna use spaces here. So the first space from where we're at right now to the first space is the mode of one file. From that space to the now, and 20 bytes after from the now, that's our hash. So we want to get what the next space is. So let space, the first space position, first space position, I can just say tree, and position or p is equal to space. mismatched types. Oh, found U81. Should do this. Okay, guys. Okay, I get it. What should we use though? We can't do that. We can't do that. P is equal to what should we use here? What should we use here? U8. But isn't this a U8? Isn't this a byte? Yeah, they want an actual thing, because okay, the tree are U8s, but I want to represent a space. I want to represent a space. Does this work? Does this solve our problem? Indeed it does. So we now know what the first space is. So from where we're at, right, from where the tree is at, this now position, to the first space position, that's our first mode. So we can just call this mode and just get it. We can just get the mode. So we can do. What can we do here? What do we do? So we just get into the tree. Just need to get into the tree. I'm thinking of the best way. This could be so inefficient. Could be the most inefficient thing ever done in the history of the universe. So let's get from where we're at to the first space position. Okay. So it's our mode. I think it'll be even more useful if we just create a struct of a tree entry. So we can have our mode, which will be a string. I'll just keep it ordered. Name, which will be a string. Then our hash. This could be a string, or we could just preserve the actual bytes, but anyway, let's just put it as a string for now. Then we'll see. So our mode is from that to the first space position. Mode. The name is from the first space position to the 0. So let's just find what the 0 is. So we're going to let tree. Oh, sorry. Now value position. So position where our p is equal to 0. Failed to find now position. failed to find null position. Okay, so now in order to get the name, we're just going to navigate the tree from the first space position to the null value position. Beautiful, beautiful, beautiful. We have our name. So these are in bytes right now. Then I need to convert them to strings. So our hash is from the null value position plus 20. Yeah, because we know it's 20 bytes. Hash. So now value position. But wait, how are we moving here? Are we including the current position or do we not? Anyway, we'll see. Plus 20. Now value position plus 20. No. Now value position to now value position plus 20. Yeah. Okay, so we have a mode, name, and hash. So we just need this as strings. We just need these as strings. How do we do that? Mode to string. Is it that easy? Read to string. Yeah, okay. I guess we can use then you can let's just do this then. So we can just let mode string new. Okay. Mode dot read to string mode. Does this work? Imitate variable mode. Hopefully it does. wait, I always use the word hopefully when I'm writing code. I need to cut that out. I need to stop hoping. Shit should be certain. This should be certain. Do the same thing here. Int hash string new. Hash to read to string. Mutable reference. Oh, this is not mutable. So we have that, and we now can have our entry is equal to tree. Let entry tree entry, and we can have our mode. There's our mode here. Name hash. So we have our entry, and we can use tree.push entry. Oh, it does. It does need to be okay. Failed context. Okay, so we need to update the tree so that we move forward. That's the best way to do that. So tree, do we ever deal with the tree? Oh, yeah, I mean we do, but this is no tree does that, tree does that, tree does that. Anyway, so we're just gonna need to do tree is equal to tree now body position plus 20 to that. Okay. Yeah, so now we just like keep on going through the tree until it's empty. So once we do that, we are so we're just gonna collect them and print them. So the thing with Git, it uses its own weird it's very weird type of sorting out when you do an ls tree. It's pretty weird. So okay, it's not very weird, but I'm just not going to do it. I'm just going to should I sort it, you know? I can just ignore that, but let's see entries dot sort, but we can pass in a closure. Let me see how. Yeah, it's not satisfied. We would have to make to implement our own sorting on the struct, but I'm just going to use derive and just put in come on guys, what am I looking for here? No, I'm gonna put in partial equal. Come on, that's not what I'm looking for. Partial order in order. Yeah. So it's just gonna do a natural sort. Git does not do a natural sort. It does an unnatural sort. So yeah, so now we're just gonna go into this for entry in entries and just print it out. So we're just gonna print line entry. So of course right now we format arguments be string neutral. It won't work because we haven't implemented display for our tree entry. We could use this, you know, it's a cheat, but we could also implement the trait on tree entry. What should I do? Should I just, I mean, I've been hacking this entire time. I should just hack it again, right? I should just do the dirty thing. Does it work? It doesn't take the error away. Okay. Because it doesn't implement debug. Come on. Show. Yeah. Okay, let me just implement it then. We don't need to. So we're gonna implement the standard format display for tree entry. So I can just implement the missing members. So how does this work again? Right. Yeah. So write the output and the thing. Yeah. So write write, what's the output? Output is F. So we're gonna do F. Wait, what's the example again? What does this look like? Okay. Yeah. Just gonna format. So we're gonna use self, of course. So we're gonna write into this formatter here, the F. So wait, am I allowed to use the format? Do they use the format in the example? Formatted arguments. So you can just it's already like that. So okay, tree entry, and just say self dot mode, self dot name, self dot hash. I don't have a lot of faith in this implementation, especially with this positioning. This is the I just don't I don't how is this file treating position? How do slices treat positioning? Because if I'm wrong, we'll have to do a +1 here, do a +1 here, and do a +21 there. But maybe this works. Yeah, that's why the Rust gods implemented testing, the programming gods. Think the programming gods. So we want to have a tree object, which we don't have right now in order to test this. So let's create a tree object first. Then we read that tree object. What is the right tree? Yeah, okay. For the moment of truth. For the moment of truth. Cargo less tree. Let's go. Failed to find first space position. Okay. Why have you failed to find the first space position? This is like the first thing to do. So tree, that's the tree. From null position, it's go to 0. So from null position, this is so crazy. Null position, we do find the null position then. So we're here. Well, this is the null position. So we're able to find this. And we're not able to find this. How? How, guys? How? And we do switch from null position towards this. Or maybe it's using, but even if we were still here on the null position and using the null position, we would still be able to find the first one. Let me just see. Okay. But so it ran, but there's nothing outputted here. So what happened? What happened? Maybe this is the first space position. Okay. So first space position. So I think we're gonna need to adjust here. First space position. Read to string. The first space position. What do we even read in the mode? Do we even find our mode? This is the mode. What the hell? Well, tree is not empty. Do we find an empty tree? Is our tree empty? Our tree could be empty. Yeah. If tree is not empty, okay, if tree dot is empty, print line, tree is empty, folks. I think our tree might be empty. Yeah. How do we fix that? How do we get a non-empty tree? Oh, I mean, but I am checking after this, so it's not empty. It's just that the rest is empty. So we are at our null position, and we're trying to get everything after our null position, and that's what's empty. Everything after our null position is empty. But why? Why is that the case? Why is that the case? We have our things here. Get right tree. Is there another command we could use? Get. No other command. Get right tree should write the tree. So there's something absolutely wrong here. No position. Okay. Okay, let me just prepare some coffee. Okay. So right tree. So actually we need to git add first. Git add, that's when we can write a tree. Yeah, because we were just getting an empty entry. So now we can do a cargo run and paste in this. Let's go. Okay. Stream, this is the mode. Okay, so everything else is working. Failed to read hash string. Failed to read hash string. Okay. So that's okay. So this is the mode. The mode, we can read the mode. Okay. The name, for to read name to string. Okay. No problem. problem. So what's our null value? Okay. So our mode is from where we're at to the first space position. Okay. That sort of works. And our name is from our first space position. So we need to do a +1 here. So we start from the byte after the space position, because right now we're gonna have a leading space towards name. Then our null value position, exactly what is 0. Okay. Then our hash is from our null value position. So here we want to do a +1 to null value position +20. Null value position +20. So I want to do a +1 here too. And since hex encode, I need to encode this since it's in binary. I think maybe that was our problem. So we don't need this here since we already have a string. Okay, let's try that again. Stream did not contain valid duty. Failed to read mode to string. Failed to read mode to string. So that means we did read the hex, then we went to like a second entry while we failed to read the mode. Okay, I mean mode is the first thing, right? So that means we did get this. I think maybe we should this should also be +21. Let's try that again. Come on. Yes. 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 Okay. That's amazing. That's amazing. That's fantastic. That's fantastic. That's fucking fantastic. So we're just gonna, because if you do a git ls tree, and do a git ls tree, oh shit, git ls tree this, yeah, you have that. So we need oh, there's a 0 here. I'm just going to ignore that. Just going to ignore that. You know, you can put it there, but blob or tree, we need to differentiate between a blob and a tree. So if it's this not value, it's a blob. If it's this, it's a tree. So we need to be able to do that. Cargo run. We need to do that for here. So we're just gonna implement an enum called kind, and this will have blob and tree. So we can implement a display for this. Format display for kind. Okay, come on. Implement the missing members. So with this, what do we do here? We can match on self. Imagine self. So if it's self blob, we can write self kind self tree. We're gonna be writing tree. Yeah. Okay. It's going into F. It's going into F. I'm sorry. It's going into F. It's never used. We're about to use it. We are about to use it. So tree entry. Should we put in a kind here? Should we put in a kind here? Should we put in a kind or what? Yeah, I think that would be great. Kind. Okay. Okay. So if mode okay, let kind equal to if mode is equal to 100,644, then that is a kind dot blob, else it's a kind tree. Then here we can just have kind. How's that, guys? How's that? Is that good enough for you? What? Then baby, go back then. Oh, did I entry? Oh, I forgot to add this. This should be here. And if that's not enough for you, well, baby, go back then. Is that enough? Yeah, that's enough for him. That's enough for him. Okay, I gotta go now. I think there'll be a part 2 while we continue off, but this is just a minimum implementation for today. Thank you for coming. Adios.